The ratio of energy required to raise a satellite to a height h above the earth to the radius r to the kinetic energy of satellite into the orbit is. So basically our aim is to find out what about the ratio of energy required to raise the satellite from the surface to a height h. So assume that initially it was on the surface. Now we need to raise it up to a particular height, let's say that is equal to h. So we can find out what about the value of energy required for this process on the assumption that we are just changing the potential energy. So we can write the value of its work done, or the energy required is, we can take it as potential energy final minus potential energy initial. We are not changing its kinetic energy. Just to change the position we need to put some energy. We are going to find out that energy. So total energy final we can take it as minus of gmm divided by distance from the center. We can take it as r plus h, and potential energy initial is minus of gmm divided by, we can take it as r. So we can write this as equal to, if you are taking gmm as common, so remaining thing is minus of 1 divided by h plus r plus 1 divided by r. And if you are taking this h plus r into r as LCM, if I am taking h plus r into r as LCM, so it is minus r plus, we can take it as h plus r. So this minus h and plus h get cancelled. We'll get as it is minus gmm into h divided by h plus r into r will be the value of this energy required for this process. Then next we need to find out the value of kinetic energy. Let's say this energy is even, and kinetic energy of satellite, which we can take it as E2. The equation for kinetic energy is gmm divided by 2r, where we know that the value of this r is nothing but the orbital radius, that is r plus h. Now our aim is to find out the ratio of these two things, E1 divided by E2, so which is gmm into h divided by h plus r into r divided by E2, which is gmm divided by 2 into r plus h. So this gmm and this gmm get cancelled, this r plus h and this r plus h get cancelled, this 2 will come on numerator, so it is 2h divided by r will be the ratio of this.